Hello students, myself Mohammad Adil Sheikh, an assistant professor of Chemical Engineering Department from LJIET Institute of Engineering and Technology. Today I am going to take a lecture of a mass transfer operations 2, and in this video we will see the experiment about a packed bed distillation column. Okay, so let us start the video. So the name of the experiment is a packed bed distillation, and the aim is to purify the methanol from the water system by the distillation. And this is the instrumentation, that is a packed bed column which is being used for the distillation purpose. So as you can see, this is the packed bed column which is being used for the distillation. Okay, now the working principle of the packed bed column. So basically the packed bed columns are used for the distillation or gas absorption or a liquid extraction purpose. The gas-liquid contact in this column is a continuous and not a stage-wise. Liquid flows down in a column over a packing surface and vapor moves countercurrently up from the column. This provides a large amount of surface area per unit volume to facilitate liquid vapor mass transfer. So as you can see in this figure, that the packed bed column which is being used for the distillation or either gas absorption or either for the liquid extraction purpose. And in this column, the gas and liquid are contacted in a continuous manner and not as a stage wise like a tray tower. The liquid flows down in a column over a packing surface, and so the vapor will move countercurrently upward while the liquid will flow downward via packings. Now through the packed bed column, the large amount of surface area per unit volume of this liquid or a vapor will be available for the mass transfer between the liquid and the vapor. Now the construction of the packed bed column. So the experimental setup will contain different units like a distillation column, condenser, reboiler, reflux valve, feed pump, several tanks like feed tank, cold water tank, product and bottom tanks. Now here the distillation column will be SS material, that is a stainless steel, and has a diameter of 80 mm and is of height 900 mm, and it will be packed with a rasting ring packings. The condenser has a diameter of 75 mm and a length of 500 mm with a 12 number of the tubes inside it. The reflux reboiler is a horizontal type reboiler. Now the tanks are actually made of stainless steel, again 304. So the feed tank is having capacity of 30 liter while the product and the bottom tanks are having capacity of 15 liters each. The rotameters are provided to measure a flow rate of a feed, bottoms and also cooling water circulation of the required range. So basically there are rotameters which will be provided to control the flow of a feed, bottoms and cooling water circulation within it. Okay, so this is how the construction of the packed bed column, or you can say the experimental setup, will look like. So as you can see, the central portion which is a distillation column, and it is fitted with a packed it is packed with a rasting ring packings, and there are the different rotameters also, and the temperature indicators is available on the right hand side. Now within this column, as you can see from the top, there is a condenser attached, while at the bottom there is a reboiler and also the feed tank along with a cooling tank. Okay, so this is how the actual experimental setup will look like. Now let us start with the experimental procedure of this packed bed distillation column. So first of all, we have to prepare the binary mixture by mixing both of the component, that is methanol and water, in a predetermined amounts. Then we have to charge that mixture within the feed tank, and we have to switch on the feed pump, and we have to adjust the feed flow rate by using a rotameter. And first of all, the feed will be fed through the middle of the column. Then the feed will flow downward, and ultimately it will be fed to the reboiler, or you can say a boiler. Then the level indicator which will be shown by the mixture inside the boiler. After 75% level within the reboiler, we have to start heating. Then we have to maintain the temperature of a boiler up to the boiling point of more volatile liquid, that is a methanol, which is around 60 to 65 degrees Celsius would boiling point, and so that only one component, that is a methanol, can evaporate. Now after that, we have to switch on the cooling water supply system, and we have to adjust the flow rate of water in a condenser by using a water rotameter. Now we have to note down the temperature within the columns, and then we have to when they will show the conditions of a stabilize, which means the steady state, then we have to draw the samples of a liquid, that is about 10 ml from all the trays, or you can say reflux and the bottom, and also from the top of the column. Now after that, we have to run the cooling water supply around 5 to 6 minutes so as to remove any traces of the vapors which is left in the column, that is of the methanol. Okay, then we have to charge the feed tank with the tap water and run the feed pump so as to remove the binary mixture from the taste. And also we have to charge the water from the condenser shell side to the reflux drum and run the reflux pump to clean the enrichment section of the column. So basically, after running the cooling water system, we have to feed the tap water within the feed tank, and we have to run that tap water throughout the column to remove the mixtures. Then we have to run the reflux pump to clean the enrichment section. Now do not operate there are some precautions, like do not operate the column with both the components as an organic one. Always use water as one of the component. Then also do not use the pumps to pump the liquid having temperature above 60 degrees Celsius. So basically that's why we will use a methanol over here whose boiling point is 60 around 60 degree Celsius. Okay, now let us switch to the working mechanism of this packed bag distillation column. Now we will see the working of this equipment, which is a packed bag distillation column. Okay, so this is how the actual distillation column will look like. This is the equipment setup. As you can see, the central column is a distillation column, and this is the temperature indicators, while the heater switch, and also the feed and cooling water, and also the solenoid valve switches. These are the rotameters which are used for the control of the flow of the stream. Okay, for the cooling water, reflux, distillate, and feed. Now this is a feed tank in which we will feed our solution, that is a methanol water solution. Okay, this is the pump, or you can say motor, which is being connected to the rotameter for the control of the feed, and which is connected to the this distillation column at the center, as you can see via this blue color pipe. Okay, so this is for the feed. Now here, when we will fed the solution, or you can say we will fed the feed here, so it will be collected, it will flow through the packings, and it will flow down to this reboiler chamber. Okay, here then the vapors will be withdrawn from this top of the column to the condenser. As you can see here, the feed will be connected, and then the through the condenser it will be collected into this reflux drum. After that, this is the cooling water system. As you can see here, that through this is the cooling water pump, okay, which is being used to pump the cooling water through this condenser. Then this is the reflux drum, as you can see here, through which the distillate is collected from the condenser at the top. Okay, this is the reflux pump, which is being used to return some of the distillate portion to the feed, or you can say to this distillation column again. Okay, which is also connected to the rotameter to control the flow. This is the distillate pump, as you can see, which is used to for the to remove the distillate from this reflux drum, which is also connected to the rotameter of itself. Okay, so this is how the system will look like. Now this is the cooling water outlet pipe, which is being connected to this tank, or you can say cooling water tank. Now this is the methanol which is being used for this cooling to prepare the feed solution, which is a 1 liter of methanol, while the 19 liter of the water. Okay, now we have fed this solution into this feed tank. Okay, and after that we will join this system to the power, and we will start this system. Okay, this is a switch. You can see here the green light, which will indicate that the power is on, and after that we will switch on this, and so now the setup is ready to start. Now after that we will start this feed pump like this. Okay, so now we have started the feed pump, as you can see. So the feed will be pumped via using that will be pumped to the distillation column via that pump, Okay, and this is a feed rotameter, as you can see at the center. So we will try to regulate the flow of this feed through the column by using the rotameter. Now this is the distillation column. So at the center of the column the feed will be fed, and by passing through the packings it will be collected into the reboiler. As you can see here, this is the reboiler, and this is the level indicator of the reboiler. So when the level indicator of this reboiler will reach to the 75%, then we have to start the heating. Right now it is at somewhat 20 to 25% level, this level indicator, and so we will not start the heating. Now this is the distillation column. As you can see, there are packings which are being provided here within the column. Alright, so this is how the actual setup will look like. Now after the reboiler level is obtained, then we will set the reboiler temperature to the boiling point of the one of the component, that is a methanol, because the methanol's boiling point is less as compared to the water, and so we will set this reboiler temperature to the boiling point of the methanol. So the solution will be collected in the reboiler, and this is the level indicator. As you can see, now it is around 75%, and so we have started the heating and we have set the temperature of the reboiler to the boiling point of the methanol. Okay, so this is how the reboiler will look like. Okay, now after that, as you can see here, that we will start the cooling water supply, and we will try to maintain, or you can say we will try to regulate the cooling water by using this rotameter. Okay, so we will try to arrange this value of the rotameter somewhat around 4. Okay, by using the delivery valve. Okay, so this is how we can regulate the flow. Right now it will be up to 4. Now this is a reflux drum which will be collecting the distillate portion which is being passed through the condenser. So you can say that the condenser outlet, or you can say the distillate which is being cooled, will be collected into that reflux drum. Okay, so now the vapors which will be formed from the reboiler will start going upward, and after passing through the top of the column, it will be passing through this line to the condenser, as you can see here. Then from passing through the condenser, it will be collected into this reflux drum. Okay, this is the condenser outlet, this is silver coiled, so this will be the condenser outlet, as you can see here, and it will be collected into this reflux drum. Okay, this is the reflux drum. Then this is a cooling water tank. So we will start this we have started this cooling water, and through this motor, as you can see here, or you can say pump, it will be passing through this cooling water rotameter, okay, which we have adjusted to the 4. Okay, this is the cooling water rotameter, we have adjusted to the 4, and then passing through this will following through this blue line, it will be fed to this condenser. So this will be the condenser water inlet, and this will be the condenser water outlet, and it will be fed back to this cooling water tank like this. Okay, now within this reflux drum, when we will collected enough reflux, or you can say enough distillate, then we will start this reflux pump, and we will reflux back the amount of liquid, or you can say solution, by using this reflux rotameter. Okay, so we can adjust the flow of that, and then we will reflux back this this solution into the column along with the feed. Okay, this is the reflux drum. As you can see, there is a liquid which is collected. Now after the steady state temperatures are achieved, we can find out the temperatures of the channels, that is the T1, T2, T3 and T4 will indicate the temperature starting from the bottom of the column to the top of the column. Okay, so this will be the T3, then the T4, so this will be at the top of the column. Then T5 will indicate the temperature of distillate which is fed to the condenser. Okay, then T6 will indicate the distillate outlet temperature from the condenser, and 7 number will indicate the cooling water inlet. as you can see, this is the 7 number, which is a cooling water inlet, and the T8 will show the cooling water outlet from the condenser. Okay, so this is how we can find out the temperatures once they are steady state. Now after that we will start the valve, or you can say the distillate pump, so that we can have the distillate force which will be done by using this distillate rotameter. Okay, so we can adjust the flow of the distillate by using this rotameter, and from this pipe, as you can see here, we can have the distillate which is being collected into this bucket. Okay, very small amount of distillate will be collected here for the reference portion, and from the bottom of this reboiler, as you can see, through this valve we can have the bottoms composition. Okay, now we have to prepare an observation table. So first of all, these are the observation, the amount of feed solution. Here we have taken 20 liter, where 1 liter is methanol, while the 19 liter will be the water. And so the concentration of methanol in feed in percentage V by V, the XF will be 0.05. The flow rate of the feed we have adjusted to the 10 LPH. Flow rate of the cooling water was adjusted to the 4 LPH. Flow rate of reflux was 1.5 LPH. Now from this volume we can find out the density of the feed, and so it will be 989.6 kg per meter cube. Here the density of methanol is 792 kg per meter cube, but the density of the water is 1000 kg per meter cube, and hence the density of this feed solution, which is 20 liter, will be ultimately 989.6 kg per meter cube. Now the boiling point of methanol is 65 degrees Celsius, while the boiling point of water is 100 degrees Celsius. Then the top product and bottom product, which is being collected as a distillate and residue, should be written here. Okay, and after that we have to draw the table like this. So these are the temperatures, that is T1, T2, T3 up to T8. Okay, T1 to T4 will be the different locations within the bed. Okay, and T5 will be the distillate inlet, which will be inlet in a condenser. Then T6 will be condensate outlet. T7 and T8 will be the condenser water inlet and outlet temperatures. These are the different temperatures which are being shown here while during the experiments. Okay, so this is how we have to make the table of, or you can say, observation table. Now after that we have to take the samples, or you can say, and we have to do the analysis of the top product and the bottom product. So the top product we have collected for a first half was 20 ml and its weight was 16.302. So from that we can calculate the density, that is 815.1 in kg per meter cube, and from that the methanol percentage in distillate was 88.89. and similarly we can do the analysis of the bottom product. So it was 50 ml and the weight was 49.515 gram, and so the density of the bottom product will be 990.3 kg per meter cube, and in that portion the methanol percentage will be 4.663 in that is the XW. Alright, now we will switch to the calculation portion. So here within the calculation, first of all, the methanol content in a feed will be XF into V, that will be 0.05 multiplied by 20. Okay, then the methanol content in a top product will be XD into volume of the top product. XD is a volume percentage of methanol from the graph, or that is we have calculated. Then the methanol content in a bottom product will be XW into volume of the bottom product, and here XW is a volume percentage of the methanol from the graph, or else we have the calculated earlier. Alright, and so the percentage recovery of methanol will be methanol content in a top product upon methanol content in the feed. So this will give the percentage recovery of the methanol. Now this is the these are the two graphs here which are shown. The first one is the methanol percentage versus density. So from that we can find out the methanol percentage, or else that we have calculated for the different densities. And then the second graph is of the methanol water equilibrium data, that is versus Y star versus X. Okay, so this is how we can calculate the methanol percentage, and we can find out the percentage recovery of the methanol within the distillate. Okay, so this was about the packed bag distillation column, and so here the aim was to separate the methanol from the water, and so we find out that within a distillate it was 88.89% methanol was obtained. So this is how we can separate the methanol from the water by using a packed bag distillation column. Okay, this was it about the experiment. Thank you.